graph all vertical and horizontal asymptotes for the given rational function. And here we have the function f of x is equal to x squared minus 4, all divided by x squared plus 2x minus 3. Now, before we dive into finding these asymptotes, the first thing we should always check when working with rational functions is, can we simplify this function further? So that's where we're going to begin. We want to check if we can simplify. So we'll put simplify question mark? I don't know, let's find out. So we have f of x is equal to, we've got in the numerator, that's x squared minus 4. And in the denominator, we have x squared plus 2x minus 3. So we are going to factor the numerator and denominator separately to see if any common binomials exist. So in the numerator, we see, hey, we have a difference of squares. We have x squared minus 4 squared, which is 2 squared. So we can rewrite this as x minus 2 multiplied by x plus 2. Beautiful. Now, in the denominator, we're thinking to ourselves, what two numbers multiply together to give us a negative 3, but combine together to give us a 2? 3 and negative 1. Woohoo! So we can rewrite this as x plus 3 multiplied by x minus 1. Now, do we see any common binomials? Nope. So this is as simplified as this function can be. So now that we have checked that this function is simplified, let's go ahead now and find the vertical asymptotes. So we want to keep in mind with vertical asymptotes, these are the zeros of the denominator. So to find if any vertical asymptotes exist, we are going to set the denominator equal to 0 and solve for x. Now, conveniently enough above, we already factored our denominator. So we can use that factored denominator. We have x plus 3 multiplied by x minus 1 and set that equal to 0. So this is set up perfectly for us to consider each binomial case. We have the case where x plus 3 is equal to 0, and we also have the case where x minus 1 is equal to 0. So in case number 1, to isolate x, we are subtracting 3 from both sides of the expression, and we see 3 minus 3 cancels itself out to 0, leaving us with x is equal to negative 3. And in case number 2, to isolate x, we are going to add 1 to both sides of the equation. Minus 1 plus 1 cancels itself out to 0, leaving us with x is equal to 1. And so we've done it. Woohoo! We can say that, therefore, this function has two vertical asymptotes at the vertical lines, where x is equal to negative 3, and where x is equal to 1. So we'll keep that in mind when we go to sketch these asymptotes. But first, we need to find if any horizontal asymptotes exist. Now, remember, with the horizontal asymptotes, here we are going to be comparing the degree of the leading term in the numerator to the degree of the leading term in the denominator. So in order to compare these, we need to think about the function, the whole rational function as it was originally written. So that was x squared minus 4 all over x squared plus 2x minus 3. So looking at our numerator here, we can see that the leading term is x squared. And looking at our denominator, we can see that the leading term is also x squared. Now, since the degrees of these leading terms are equal, or since the degree in the numerator, 2, is equal to the degree of the denominator, 2, then the function f has a horizontal asymptote at the ratio of the leading coefficients. So looking at the leading term x squared, keep in mind that we could equivalently write this as 1 times x squared. Same thing with the denominator. X squared can be rewritten as 1 times x squared. So the horizontal asymptote then is going to exist at the y value equal to 1 by 1, which simplifies to 1. Woohoo! So this is our horizontal asymptote for this rational function. And we're now officially ready to go ahead and sketch these asymptotes on the coordinate plane. So we are ready to sketch the asymptotes. So we need to think about the xy plane. Now, thinking back to our vertical asymptotes, we know that we have two vertical asymptotes. We have the first vertical asymptote when x is -3, and the second vertical asymptote when x is 1. So looking at the xy plane here, here's where x is -3. And so at this point, we are drawing a dotted vertical line to indicate that this is an asymptote for our rational function. And we'll label that VA for vertical asymptote when x is -3. Now, moving to the other side, to the positive x-axis, here's where x is 1. Now again, we are going to draw a dotted line, a dotted vertical line, to indicate that the rational function has a vertical asymptote here. And we'll label this again VA for vertical asymptote when x is 1. Beautiful! Now, thinking back to our horizontal asymptotes, we know that we have a horizontal asymptote when y is equal to 1. So on the xy plane, here is where y is equal to 1. And we're going to draw a dotted horizontal line all the way across our graph to indicate that the rational function has a horizontal asymptote here. So HA for horizontal asymptote when y is 1. And so there you have it. Here is the graph of the asymptotes for our beautiful rational function.